Hey, hi everyone. Sorry to interrupt the probably very nice discussion that you're having. I know that pizza it's outside, so everybody can probably smell the pizza. I will try to be, as short as possible and try to make it a little bit of fun and learning experience for you all. I think I sometimes forget to introduce myself, just assuming that everybody knows me, but it's probably not the case. As you probably know, I'm not Polish. I come from Mexico, and like 3 years ago, I wrote an article on LinkedIn, and it was on machine learning operations, and somebody in Poland read it, and they offered me a job, and that's literally how I got here. I find that the story to be interesting, so that you guys take LinkedIn seriously. Maybe you land yourselves in Mexico and you do the reverse trip that I did. It has been a very interesting story for me to be here. I didn't choose lightly to come here. I had a very stable job over there, very nice car. I had to sell my car, use the tram, very nice tram system you have here. But I did it for a reason, and this is because I thought to myself, one day I'm gonna be here in one of these universities that Poznan has to offer. Not sure if you know this because you're from here, and maybe you're not such Googling about Poznan as I did a lot, but Poznan is the country in Poland that has the most amount of universities per capita. And yeah, and I actually work in Roche, which is one of the largest biotech pharma companies in the world. So let me just talk to you about from hand process to assembly line machine learning operations. And before I start, this is a very nice, I'm very happy I'm next after talking about Agile, because I think everybody here has heard about ChatGPT and machine learning. If you haven't heard about ChatGPT, you probably have been living under a rock. And if you are a bit more advanced and you know what machine learning or AI is, then this talk is definitely for you. But yeah, because I come from Roche, and Roche has a big office here in Malta Lake, not too far from here. I want to talk to you about, what do we do at Roche? Maybe one day you apply, maybe one day I interview you, and it will be nice for you to ask a bit of questions about Roche and basically pharma industry in general. So what do we do? So we transform science into medicines. And to be honest, this is actually a very difficult task. Science into medicine. It actually takes a lot of time to transform science into medicines. It's extremely expensive. So one single drug that makes it into the market costs $1 billion approximately, and takes about 10 years. So and it's a bit of a gamble. So you have you have certain drugs that you feel are going to make it into the market, and maybe they fail during clinical trials. And this happened to Roche this year a couple of times. And then this is difficult, right? Because we as a company don't have the certainty that, it's not like we're building a car and we are very confident that we're building the super advanced car, like the Tesla Cybertruck, and it takes a lot of energy, a lot of engineers, but people are gonna want to buy it. We don't have that certainty. We pay a bunch of money to a lot of engineers, a lot of scientists, and we could potentially fail. The whole thing can fail. So $1 billion. And so yeah, drug discovery process is very, very difficult. And what do we do? We have multiple molecules that are candidates. So we want to basically try to predict if one of these guys, how do I put the laser? Oh, this is so hard. Wait a second. Oh, look at that. So we have a bunch of, let's say, candidate molecules. So we have a database, literally a database, that has information about 1 or 2 or 3 or actually hundreds of billions of molecules. And we need to predict which ones are we going to make, which ones are we going to prioritize, because we cannot hire 1 billion scientists to do one experiment each and then let us know which one actually worked. There's just 10 billion people on Earth. So there's not enough bioinformaticians, there's not enough scientists. We need to choose, and we try our best to choose the best ones based on some criteria that we can find. And this is where AI comes into play. So we use artificial intelligence to choose the top molecules that have the largest chance of making it all the way to cure cancer. So if you don't know any drugs made by Roche, you are very lucky because you are not a cancer survivor, or your family is not, cancer survivor. So Roche works in these drugs that are the worst kind of diseases for humankind. So, we are actually, this really inspires me to do my job the best that I can, because I can actually help someone, live a bit longer, or get, all the way to when they're old. And of course, what we want to achieve is some kind of, after a lot of iterative process, we drill down from like billions of molecules to one, and then it has to go through human trials. And of course, it can fail, but we try to make it all the way there, because that's when, when you can actually take the drug and get cured. So how can we do machine learning at scale? So this title of this talk was about assembly line. As you probably heard, everybody has heard here about the Model T car, like this Ford car, no? I don't know, maybe you haven't, but a long time ago, in the year 1900s, the beginning of the century, there were no cars, or there were very few cars, and Henry Ford came up with this idea of saying, wait, we cannot actually. He wanted to sell cars to absolutely everybody. Like, he wanted to build everybody in the US to have a car, and he thought of, hey, why don't we build assembly lines? And assembly lines actually drop the cost, and everybody all of a sudden could afford a car. And this is kind of what machine learning ops is trying to do. Nowadays, machine learning is basically a bit of niche. It used to be a niche that few companies can actually hire a data scientist. As you probably know, data scientists can make hundreds of thousands of dollars, up to like $500,000 per year in salary. So it's very niche, and few companies can actually get there. But if you start as an industry, we are starting to turn like machine learning into like kind of assembly line, so that instead of producing one machine learning model that this guy built, that we're paying him a lot of money, we maybe build 1,000 machine learning models one year, and then the next year we build 10,000. So everybody, let's say, could get their hands on this progress. So as I get a bit older, I start reading books about business, because that's what older people do. But I read this book that is actually very nice. I took this kind of quote from this book, and this guy is talking about how to build great organizations, and I'm just trying to learn how to be a better leader for my team, because a long time ago I was a student. So it takes some energy and time to become a leader and to learn how to help others succeed. And basically, I came across this quote that says, those who build great organizations, and by organizations, you can think about Google Developer Student Club. So you can scratch that and say, those who build great Google Developer Student Clubs, make sure they have the right people on the bus and the right people in the key seats before they figure out where to drive the bus. So if you guys have, for example, the right person in marketing, and you have the right PhDs in the team, and you have it all together, you might not know what to do, but if you have the right people, then you can actually start thinking about getting somewhere. So let me see the time. Okay. No. Pizza is it's not gonna. I mean, I'm not gonna get out of here alive if pizza gets too cold. But anyways, so the core of the talk is in front of us. So MLOps, this is. Can you please raise your hand if you have heard about DevOps? Okay, yeah, DevOps, great. So like 30%. Okay, so DevOps is developer. It's basically what we were talking about in the previous talk. Previous talk was talking about this waterfall process that you have some kind of requirement gathering, and then you start funneling all the way to slowly moving things from what the client needs to the actual final product, and then that whole cycle is like a waterfall. And DevOps is taking developers and operations into one single team. Actually, she talked about DevSecOps, but think about DevOps for a second. And of course, we are trying to build this kind of assembly line in machine learning, and we are doing it with the use of something called MLOps, or machine learning operations. So the problem is that it's hard. But what I said in the previous quote, I'm trying to build the best machine learning ops team in the world. That's my goal. And for me, it's important to first define, okay, going back to my business quote, let's make sure we have the right people before we figure out where to even drive the bus. And you have to have, if you're trying to build a machine learning ops team, or if you're a student, and if you're trying to see, okay, what skill sets are in high demand today in the world, so this is it. Backend engineering. So in my team, we have backend engineers which manage in like cloud native deployments using Kubernetes, using the cloud. So we have cloud engineers that know very well how to manage all the infrastructure. Just infra layer is very important. We have DevOps engineers who build this continuous integration, lots of buzzwords, but continuous integration, continuous deployment pipelines, or CI/CD pipelines. Oops, wait a second. Of course, software engineers. We need good software engineers. Engineers who actually can just write Python and then like add a bunch of print statements everywhere and then just get it to work, or just know how to work in Jupyter notebooks and that's it. No, we need actual software engineers who follow good clean code and all these good practices. It actually really matters. And data engineers and data scientists. So somewhere in the middle is basically what I do. I have to work on all these fields at the same time, but it's a bit, kind of hard. I used to work in a team in the US that was full of data scientists, and I was the only non-data scientist, and I was basically playing the role of backend engineer, and that didn't really work. So we spent a lot of time talking in the meetings about data science and the latest algorithm, and it was very fun. I studied physics, by the way. I didn't introduce myself that part, but from physics, I worked on computational physics, and then I started in IT from the bottom. I will maybe talk about it later briefly. But then, yeah, I was already, let's say, somehow I managed to learn a lot about the cloud, AWS, and I managed to learn about Kubernetes and just kind of became expert in this kind of world. And I liked data science, so I learned a lot about data science, and I was hired into this team. But everybody there was data scientists, and the team failed, even though the people in this team were genius. Every single one of these guys on the team, when the team failed, they went to Microsoft. One guy went to Meta, or what used to be Facebook. Another guy became chief technology officer at 24 years old. I'm not joking about this guy. Talked to him the other day, and he's still CTO. I said, like, are you still CTO of this? Yeah. I'm actually still CTO, and he lives in Australia. And even though we had like crazy people in the team failed. Like, we just had a bunch of data scientists. So, you can maybe remember, like, if you're trying to build a team, just make sure you have a bit of every different kind of skill set. Doesn't matter if it doesn't have to be MLOps, but if it's MLOps, this is the secret sauce. So, not too long from here in Malta Lake, there is an office from this company that I work for. And as you can see, Poland is actually the only country in this company of 100,000 employees that has 2 offices. So we have an office in Poznan and an office in Warsaw. Maybe that's not true. This is a Swiss company, and we have also multiple offices in Switzerland. But aside from Switzerland, that's it. Why Poznan, actually? This is an interesting, because you guys are students. I'm in Poznan. Let's actually drill down on why they opened 2 different offices, one in Warsaw and one in Poznan. I don't know if I have enough time, but I talked to the person who decided to open the office in Poznan, and they were checking where to open it. And this company has a lot of money. They have a lot of budget to open it wherever in the world they want. And they checked all the cities they checked Dansk, they checked also other Czech Republic, Hungary, so all the areas around like Warsaw, close to Warsaw, and Poznan won the bid for having the highest number of graduates in technology, for having airport, they have a nice connection train and infrastructure, so you live in a privileged city, and just wanted you to know that. And so yeah, we are Roche Informatics. It's a 125-year-old company, and it's actually Roche Informatics is delivering technology that evolves the practice of medicine, and we help patients live longer, better lives. That's what we do. And I just talked about machine learning ops. Very quickly, I showed you some of how to build a team of different experts. But I will take a step back and just talk about what is MLOps. And this might be very useful in a future interview, because I believe MLOps will just continue to grow, probably into different kind of acronyms, maybe MLSecOps or large language model ops. It's a thing for things like ChatGPT are using this framework to operationalize their large language models. So whatever the acronym is, it's useful for you to know why doing machine learning is a bit difficult or special. And I think I just broke this. No, okay. So MLOps is a set of practices that combines machine learning, DevOps, and data engineering, which aims to deploy and maintain ML systems in production reliably and efficiently. And let me give you an example. I hope this visual way of showing you like a pipeline sticks in your brain so that you remember something out of this day. But if you are working with code, only with code, you can produce software that it's future-proof for many years in advance. Like if you're a very good developer and you did your homework and actually read a lot of books after you finish your degree, and you become this top expert in software, which is totally possible. If you're only dealing with code, the code can actually be working perfectly for many years, right? That's totally possible. Maybe a good example is Windows XP. It's still running and it's not being updated anymore. I think in 2000 they stopped updating it, and it's still running, But the problem is that if you, maybe not very well, but it's still running. But the problem is with data. If you have the perfect software at the bottom, and you have some pipeline, continuous integration, you have testing, you are doing everything great, but then you are including into your production deployment, you include data. Well, the problem is that data usually comes from real-world events, no? So you have, you can have, for example, machine learning pipelines or machine learning models that are super well done. They have the best, code, and everything is just basically done in perfection. But then what happens if the world changes? And this happened. So there's a lot of banks that have these detection algorithms, machine learning models that detect fraud, like fraud detection. If somebody steals your credit card information and they buy a Lamborghini, and you usually are not and you have enough credit to buy a Lamborghini. If you never bought any car in your life, or let's say something smaller, let's say that somebody goes and buys a MacBook Pro or an iPhone or an iPad or whatever. And if you are only buying cooking stuff because you're a chef and you hate technology, and all of a sudden you buy an iPad, this can actually be suspicious, no? I mean, this is what the model is trying to detect, abnormal activity in your account. And the problem is that all these banks in the world had machine learning models that were trained with historical data of all the customer patterns. And then COVID came. And when COVID came, everybody stopped buying physically in stores, and they started buying online. And imagine you have a period of 10 years you've never bought online, and then you buy 5 things online. So all the credit cards were getting blocked by real, not by hackers, or people were actually just trying to buy toilet paper or whatever that was missing during pandemic. And the problem is that the layer above changed. So the world changed, the data changed, and the pipeline failed. And what happens is that you have to then retrain the model and then like get latest data and do the whole thing again, and then you get a new model that is like accurate again. And then this is what machine learning is trying to, ops is trying to tackle. If you take a look at this pyramid, a simple way of remembering what is important when it comes to making good machine learning models is that you have to have high quality code and DevOps. So you have to automate the code deployments, the continuous integration, continuous delivery has to be done correctly. And you have to have high quality code. And by high quality, like you follow some like good best practices of whatever language you're using. Then you have to automate the data ingestion. So you cannot call a DevOps, like an engineer, a scientist, and say, hey, can you email me the data set? Like, can you compress the data set? And I need a new version of the model. And this is actually true. Like this happened to me. Like I got a new data set sent to me by email, and we needed to use it for training. And this is not too long ago, like 4 years ago. So this is not a good way to have DevOps. Because of course, you can make a machine learning model with a data set that somebody sends you an email. You unzip it. You put it on a Jupyter notebook, you train the model, you copy the model, you put it in an API, and you're done. But if the change is abrupt, like COVID hits, and you have to retrain 100 models, it's going to take a lot of time for you to fix all these things, and you cannot do it quickly. So this is also why you need platform automation, so it's some kind of machine learning platform that can help you retrain the models quickly, and then you actually can achieve MLOps. So if you work with like Jupyter notebooks, you need to move away from them and move into manageable functions and code components. This is actually very important, and I see this done incorrectly many times. Like you need, for reproducibility, you need to track your code, your environment, dependencies, parameters, artifacts, data, and even infrastructure as code. So this will be like interview questions from me. I interview people for coming into my team. And I ask them like, okay, so you're a Python developer. And what do you do? Oh, yeah, I know how to do this and that and that and that. And I'm very good. I read these books, and I'm actually very good. OK, so how do you manage your environment? And they're like, well, I do pip install. And that's like, well, that's how you install it. But how do you manage? Like, how do you make sure that you have exactly the same version of all the different Python packages, like in your laptop, than in the cloud, so you have to be able to think about these little things. Because if you know Python, there is a famous package called pandas data frames. No, then they change. They have different versions. So the way that the data gets pre-processed and aggregated, if it's version 1 of pandas or version 2 or version, they can actually have a different output, and then the whole pipeline is different from the one you have in your laptop than the one that's in the cloud. So you need to think about like dependency management and all these things. And there used to be a lot, like 10 years ago, there was a big hype of like data science, and it was all about the model. Like let's build the best model, the most accurate model, and that's it. But now the focus is not on the model, but on the pipelines that build the model automatically. So you create, automatically you pull data from here, you pre-process automatically the data here, then you train the model here, you deploy it here. That's actual value right now, and we don't put anything in production that was just made in a laptop. And you need to put a lot of emphasis in testing and monitoring. So a couple of lessons learned if you are going to, like from the, let's say, professional world, is that you want to build something that's reliable. And this, by the way, is very old concepts. It's not something new that I just discovered last week. It's a book that I found that it's like 10, 20 years old, and in this world it's like ages, no? And reliable systems, just tolerating hardware and software faults, human error, scalable. So you want to measure load and performance, latency percentiles, throughput, maintainability. You want to have operability, simplicity, and evolvability. Also, whenever something is like in great demand and there's a lot of hype, there's a lot of people are going to try to sell you that, oh, you need a feature store, oh, you need a vector store, you need a vector database, you need this and you need that. And of course, it's just, startups that want to sell you whatever they're doing. But when you are in the real world and you want to also keep try to minimize the technical stack, like keep it very, very simple. Like what is the minimum things that I need to do to make a machine learning model reproducibly in a reproducible manner? So you need to also manage something called the cognitive load, sorry. So yeah, that's often not talked about. And then one final lesson learned, which is like something that we learned at Roche, is that not everything has to be in-house. We don't want to just build everything from scratch internally because everybody outside cannot understand what we're doing and we are too advanced. But also we don't want to have everything outsourced. So what we did is we took this kind of hybrid approach, and we created an inner source team that basically takes the best out of the open source community. We become experts in that open source. We contribute back to the open source, but then we have this freedom to move around and we can adapt. And we use, this is maybe too specific, we use something called Kubeflow for making machine learning models. You can Google it. It's really interesting, very cool. This is how you actually start building pipelines. And then this Kubeflow thing is doing these pipelines run inside Workflows Orchestrator, and we heavily rely on AWS, or you can scratch the AWS because this is a Google Google event, but it's EKS. By the way, Kubernetes was invented by Google, so that's maybe worth noting. But EKS is Elastic Kubernetes Service, so we rely a lot on Kubernetes. And I don't know, have you heard about Docker? Maybe let's just, let me ask that. Okay, good. I see about some people nodding. So Docker is great because one thing I meant, this is, by the way, this is the penultimate slide. I'm almost done. So when you are, I have a no stress, focus, and fun. I didn't read that. I should have, I should have read that at the beginning. But anyways, when you're trying to make sure that you build some kind of model, you don't want this model to work in your laptop but break everywhere else in the world, or work in your laptop, but if you lose your laptop, then or if you update the version of your your operating system, everything breaks. So Docker solves that because then you have a container. And the containers basically can run anywhere, run in your laptop, in the cloud, and it's done. The problem is that managing containers is hard. We have thousands of containers running. And then Google invented Kubernetes, which is a manager of this. So if you know Docker, you are close to you can get very close to quickly learn about Kubernetes, and then you will be very, very good candidate for any job. But it's hard. Kubernetes takes time. It's like a universe to learn. So okay, we do a lot of stuff, right? We try really hard to make manageable pipelines. We are, putting the time to have high quality code. But what are the results? So far we have 150 predictors deployed across 8 business cases. There's monthly predictions being generated. And we have 12 data products and expert systems integrated. And we use this already today for the last 4 years to predict large molecule properties, and we use this to plan experiments. This is the first thing I was talking about. We have billions of molecules. We try to classify which molecules have the best chance of making it to a drug. So by using AI, we can plan experiments. So we don't actually choose the drug that goes into the market. Of course, it's not possible. But we say, okay, scientists in Switzerland, these are the top 10 drugs that have the actual properties that you need. And they actually go with the molecules that we tell them, and they make the experiments on basically with what we give them. We classify microscopy images and select cell lines. We label news and scientific articles and alert users when they need to read something. And that's actually all. That's what we do at Roche. We are doing now what patients need next. There's a bunch of references here. I also, please connect with me in LinkedIn. I like sharing on LinkedIn things that I find interesting. And I had a QR code, but I think I added it today, which is probably why it's not like made it all the way to the last version of this slide deck. But yeah, you can find me on LinkedIn or just put my name there. It's Oswaldo Gómez. Or even better, I will just put my QR code here, and you can just come here and scan it on the way to the pizza, and hopefully it doesn't get any more cold. So thank you very much, and keep at it, and thank you for listening. And if you have any questions, just let me know. I'll be outside. Thank you.